Now let's look at an example of Poisson probability. So, in a proposed archaeological dig, the number of significant artifacts that will be found is assumed to follow Poisson distribution with a mean of 6. So this is for the entire dig. So you're doing an archaeological dig, and the number of artifacts that you will find follows Poisson distribution. Okay. So the random variable here is the number of significant artifacts. Okay. Now sample space is, of course, you start with 0 because you may not find anything at all. So the smallest value is 0, then 1, and then 2, and on and on and on. Okay. Countable infinity. Lambda is known to be 6. Okay. Now what is the probability that exactly 5 significant artifacts will be found? So R is 5. Okay, let me move this down here so we can see the formula. Alright, so now we're going to set the formula up. So equal to lambda to the power of x. So here is lambda. Again, let's make that absolute reference to the power of x. Okay. Times exp, so that's our e, to the power of minus lambda. So you have minus that. Again, make that absolute reference, close parenthesis. All right. So now we have the numerator. Denominator is x factorial, or the value of x is given as r. So divided by, Excel has a function called fact that gives you the factorial. Okay, factorial of x is that. Okay, so that's our numerator, that's the denominator, and that will give us the Poisson probability. Now, of course, Excel has Poisson function as well, so you don't have to use the formula. You can directly use the function Poisson.dist. Don't use the legacy function, Poisson.dist. Okay, so first item is the number of success, so that's that one, and then mean. Mean is the only parameter that we need to compute Poisson probability. And then, of course, we have to specify whether we want cumulative value or an individual probability. So we want individual probability, so we have to say false for cumulative, then we get probability of x equal to 5. All right, let's look at another one. What is the probability that fewer than 5 significant artifacts will be found? Okay, fewer than 5. So that means R, we want R to be 0, 1, 2, 3, or 4. Okay, fewer than 5. So 5 not included. So cumulative R that we need is 4. Okay. Then we can copy, well, it's kind of, all right, let me set it up again. Poisson dist, R is there, and lambda is over there, and we do want cumulative probability this time. So comma 1 will give us the cumulative probability. The next question is, what is the probability that 5 or more significant artifacts will be found? So here the possible values for R are 5, 6, 7, and on and on. Okay, now we have a problem. Okay, So now we cannot compute the probability of all of these possibilities and add them up. Okay, that's infinitely many possibilities. So the only way we can get this probability is to find the probability on the opposite side and then subtract that, the sum of that from 1. So we already have that probability right here. Probability 0 through 4. So greater than 5 will be simply 1 minus that probability. Okay, what is the probability that either 4 or 5 significant artifacts will be found? So we want either 4 or 5. Okay. Well, this is easy enough. Now all we have to do is to set up the formula for each of them and add them up. So Poisson dist or lambda, okay, let's make lambda absolute reference, and we have to do 0. So we get the probability for exactly r equal to 4, and then copy that down. Okay, then the border line is gone, so let's put the border line back and sum the two.